private call.
I think it was like 20.
But I think theoretically, there's got to be overhead.
I
Device.
Oh,
Yeah, because we have a B tree, doing range tree.
I think I remember, but I've been all over the place. 23 days ago was like, I don't know, 40 commits and another issues. Like,
And we, Don created three on that side for the object storage use.
More to dig into.
Yeah, we're gonna try to create a profile.
I've been unused reproductive lately.
Are you familiar with how usually productive?
Yes, thanks to the static analyzers. They're like, look here, and then a lot of times, what they like to
Testing.
is, let's say, and actually get something sometimes. There is a case where it's very positive, but we can do code cleanup, and then there's a case where there's actually a bug there, but it's not really complained about. So, it's made me unusually productive in terms of fixing tiny issues. But I did find a few somewhat more substantial ones, like the retrieval thing, where we did use up to 3. Yes. So it would delete, it would create a memory, and then we were going to B tree, which is an access to free memory. Yes.
And I'm glad you pointed it out to me.
I'm just pointing out to a lot.
Great. Come on in, last few folks. Let's get started.
Actually, I'm sorry, I didn't use the computer with what but we were in the same room together, we had the problems.
All right, welcome back. Thanks to everyone. I had a busy day of hacking and helping and discussing. So now we have time for presentations. So if you worked on something today, I'd love to hear from you. It doesn't have to be a demo. It doesn't have to be completed code. You can just come up here and say, I improved the documentation on whatever. That's great. We'd love to hear about it. Yes, you have a question?
No, I decided to volunteer, even though I'm probably cheating by saying I did things today. I just did code review. But there are 2 new pull requests I'd love to talk about that I opened.
Yeah, so everyone will have a chance to share. We'll try to keep this to 1 hour. I think we'll have prizes. I need to double check and make sure that they're here. But yeah, you want to go first? All right.
So I actually could give a brief demo or something, but okay. So there were 3 things that I really did today. The first was reviewing a lot of other people's code, the Cherry BSD stuff, Matt's RAID-Z expansion, and something minor involving what other people were working on that what other people talked about. So, and the other 2 things I did were 2 pull requests. One was something that I had done in a private branch for Crowder a while back that apparently Brian wanted, which is we had run out of the IO flags, and it's basically the enum type only supports 32 bits. So what I had done in that private branch was convert it to a uint64 with a type def. So that's in a pull request right now. I hadn't expected anyone to really want it without something that actually used it, but Brian wanted it, so you have it now. And for the last thing, it's something that, so people might know that I've been doing static analysis stuff lately, and something that I had recently found and experimented with a bit on Saturday was GitHub acquired a company that does static analysis, and they made their static analyzer available to everyone. It's called CodeQL, and it integrates with GitHub Actions. So on Saturday, I had experimented a bit with it, and then today, just so I could say I actually did something during the hackathon aside from code review, I went through the trouble of making I made a pull request so we can actually get that into the repository. So in terms of doing a demo, I can actually show you what it finds and how it works using that, my GitHub ZFS repository, although I'm not sure how I'll get to the web browser in a way that will that everyone see it.
You have to use your own laptop if you want to do demo.
Oh, yeah, I guess I can't from.
That's the
Okay,
streaming.
how do I connect my laptop
There's
to
a
this?
HDMI cable right there.
Okay, so this won't take long. This one. Now, I heard there were prizes, so this is probably more to get a prize, although I was only expecting nerd credit. Well, I am only expecting nerd credit. And this is the first time I'm using this laptop with the video app. So, this is the HDMI cable? Yes.
It's very short.
I just noticed that. So I'll just hold this. And hope Apple makes everything just work.
Is there an input button?
There should be an input button. I'm just trying to find it. Oh, here's the input button. Okay.
The HDMI.
Yes. Okay, so let me try to drag this over. Okay, so what I want here is, well, this is the WAM file, which is not very interesting. It's just a stock file that GitHub recommends. And as for giving a demo, let me get over to my Okay, so unfortunately, when you do a pull request, it doesn't actually put the results of a static analysis there. It puts it under the security tab in code scanning. And we can see here there was a branch scanned a few days ago. And if I change this, it tells us everything that it found. And there are 4 different types of issues that it found. This has a very low false positive rate. None of these are false positives, although this one, or maybe this one it could be a false positive, but I think it's something we could try fixing with this printf. But this one looked like a false positive. It turns out it's not. We have this thing here in the Lua code, which, well, the channel programs code, where we have this verify. And if this fails, well, what happens is we will call a function called SPL panic. And because of the verify, we actually are going to print what is said in here, size of buff is greater than SN printf. And because this is all concatenated to the format string, we actually will end up with this, which is a format specifier, which expects 3 arguments when given 2. Unfortunately, I can't expand the macro here to show you, but it's when you check it out, it actually becomes clear, although it really does look like a false positive until you dig into it. And there's information here explaining exactly what's wrong, and it makes a recommendation. It gives an example of what not to do. And actually, here, this is an example of what not to do. And then it has references on, well, different things like the documentation for printf, the common weakness enumeration. This is more of a security focused static analyzer rather than just a bug finding one. Let me just go through one more. This one was actually somewhat surprising to me. So we have this SN printf here in the RAID math code. And well, basically we iterate and add the offset. And this is telling us that we can get an overflow. And the reason for that is that, well, SN printf won't write past the bounds what it was told. It will give as a return value what it would have written if it had a space, which causes our offset to go past the boundary and is, well, wrong, or at least it can cause incorrect behavior. And it explains this to us. It gives us an example of code like this, which has almost the same exact code. It's just the loop boundaries are a bit different. And then it gives us its recommendation and example of how to fix it using the previous example, and then some more references and other things. So by hooking this into, well, by merging that into the repository, we will actually be able to see, I think it takes about a half hour to get results, but every pull request, if there's any sort of regression, we will be able to find out at least any sort of regression in the 100 things that CodeQL checks. And this actually supports false positive marking. So if there was a false positive, we could dismiss it. But I don't consider these to be false positives, so we're not dismissing them, even though this is very, this is probably not really a bug. It's a cleanup thing. Covality can print out this one too, where timer check, timer views. That's really in the test, ZFS test suite. It even says test here. It's actually rather smart in identifying which ones are in the ZFS test suite. I didn't do anything to explain this to it, just figured it out. So yeah, that is my contribution during the hackathon. As I said, I did this so I could say I did something more substantial than this code review, and hopefully get some nerd credit, as I consider that to be a win.
Cool. Thank you. Awesome. Cool. Who wants to share next? Yeah. Cool.
That's interesting. All right. So I sat down with Paul and Richard this morning, and we talked about ZFS issues, or ZFS and Cherry issues in particular. The first thing we talked about is the XDR on disk format for NV lists. And the problem is that the format implicitly encodes some details of the in-memory version of the structure, which change with pointer size. It was previously handled by just always using 64 bits for every pointer, which worked fine, but doesn't work with Cherry. The solution we arrived at is we're going to leave it alone, and the Cherry code is going to have to learn how to compute what size it would have been had it been on the 64-bit systems. It looks relatively straightforward, but I'm going to need a test suite to not get it wrong. So that's my last slide. And then Cherry platformers will compute on, when they're decoding, they will compute what the size should be. The obvious first solution is just get it wrong and double the size, and perhaps have to disable a few checks, but only in the Cherry case. a later version, you could actually go ahead and parse the whole XDR stream to figure out what the right sizes of everything is, and then use that number instead and trade CPU for memory. But these are all transient as far as we know. If anyone thinks that's wrong, I'd be happy to know, but that's the general gist of that. The other issue we have is we use native encoding as an IOCLs, and these literally encode the exact binary representation of everything. So when you pass in a string array, you actually pass in zeroed space for the pointers and pass that through the buffer. So that's annoying. Repacking that would be incredibly painful. And I think the solution is we just switch to using XDR encoding. The receiver shouldn't care, because the receiver gets a stream that's typed and it says I'm native or I'm XDR. And I did a quick smoke test. I just changed all of them. And a system is able to create Z pools and query them. So I think it probably works. Like more real testing, running the whole ZFS test suite is obviously in order, but I think it should work. I believe none of the code paths are like so performance critical that this is going to be noticeable. But it would be good to know that. We'll probably have to find out by running the performance tests. And then so if we switch all the senders, then sort of the problem goes away. We continue to understand native. We can use old tools. Everything works except Cherry hosts can't talk to old tools. So the sooner we make the switch, the sooner we don't have to worry about it on Cherry systems in the future when hardware arrives, because hopefully many of the systems that are using the old tools will be dead by then, and not stuck in a container or in a container or in a container. And there's other solutions to that problem. You can always put a static version of the tool that speaks the right format. But if we switch sooner rather than later, then the problem just sort of goes away and the transition is not a problem in 4 or 5 years or something. We walked through the Cherry BSD PR and made a spreadsheet of what to do with all the various things. Some of them are ready for commit, some of them aren't related to OpenZFS, and others should wait. And then some of them need to be split up. So, so we did that. And then did determine that there is no test suite that we know that anyone knows of the packed XDR, the packed NV lists. So I think we're relying on the fact that the code never changes. At least that's what it appears to be. So we need some simple round trip tests, and then we need to generate binary references and compare and make sure that we can generate the expected results and that we can unpack them correctly. And in particular, once that's written and done and tested on AMD 64, we can check on Cherry and make sure we can still read and write the streams correctly. So, and Matt was mentioning that that sort of thing would be handy if, for instance, you were to write a native Rust serializer, deserializer. So that's what I've got.
Thanks, Brooks.
So I'm glad I solved most of my problems. Now I just have to do the work.
Cool. George set up a spreadsheet so people can sign up for the Hackathon presentations. So if you want to put your name and project on that, we'll go through the list. I didn't see any next person on there that saw it yet. So who wants to go next? Yeah, go ahead.
There we go. Okay, great.
So I mentioned in my ZVol talk yesterday that I had this crazy idea, which was, could we force all applications to use ODirect via a library call interception? So let's see if it works. So I've created 2 ZVols, and I'm just gonna do, I'm going to spawn off 2 DDs to write to them. And we're going to see how long it takes. These are just regular non-ODirect DDs. Okay, 5 seconds, about 46 megabytes a second. We'll run it again. Okay, 49 megabytes a second. Now let's do the same test, but we'll pass the ODirect flag to DD. Hopefully it should be faster. Okay, 66 megabytes a second. 64 megabytes a second. Okay, so ODirect's faster. Now I'm going to take my old non-ODirect test and I'm going to put this direct command in front of bash. So I spawn out these 2 DDs in a separate shell with bash. Let's see what happens. We got 53 megabytes a second, 53 megabytes a second. Let's run it again. 63 megabytes a second. So it is correctly intercepting the library, the open call, adding the ODirect flag, and passing it to the real ODirect. And if you look at that direct command, it's just an alias for LD preload. And the cool thing about this is I added this output, and the LD preload persists for bash and then all of its child processes. So you could spawn off bash and then everything could use this. And it's actually a little bit smart because not all things will use ODirect, like trying to read from dev0 doesn't work. So if it tries to open it with ODirect and you get enval, then it'll just try opening it regularly. So it just transparently works. And you can do anything you want. You can do like direct copy, let's just copy the test file. Yeah, so I've just copied with ODirect. Ooh. That's it. Thank you.
Great. Who wants to go next? Oh, I see Alan wants to go next. Go ahead, Alan.
So kind of related to all of the stuff I've been dealing with lately, where if a pool runs into certain types of failures and gets suspended, you have the problem of all the other pools on your system become unusable as well, which can be really annoying when you have a boot pool and 1 or 2 data pools, and then one of the pools gets hung, is trying to do something when it gets suspended, and the process that was in the middle of doing something is hung with the SPA namespace lock held, which is not what you wanted it to be doing. Especially if you happen to have a lot of scripts running or something that are, for your monitoring system are running zpool status or something like that frequently, you end up those processes causing things to get hung and you're not able to keep working. So I've been discussing with people the last couple of days about the idea of, especially for interactive commands that are done by users, if they're going to get stuck because they're waiting on the SPA namespace lock that might be held by someone else for a really long time, we'd like to do something about that. And so the idea was to basically return E again from the ioctl. So if you're trying to run zpool status and you can't actually get the SPA namespace lock because somebody else is holding onto it and they're not giving it up, if that ioctl returned E again and user space would just try again and again, it would mean that you could now control C out of the stuck interactive process instead of it just being stuck until you fix the broken pool, which sometimes you can only do by rebooting until we finish the forced export stuff that I know some people have been nagging us to hurry up and finish. So to demo this, I've compiled a version that does this. Although I found instead of doing E again, I used a new ZFS error code because E again already returns an error message from the like ZFS standard error processing stuff, saying that the pool is suspended, which isn't always the case. So I made ZFS error ioctl try lock failed, and then dealt with that in user land. So now if you run zpool clear on our device under test, it works. But if somebody is stuck, so I made a little, I made my own new tunable that runs a function that when you set it to 1, it takes the SPA namespace lock and just sits on it. And now if you try to run zpool clear, you'll see it gets back that the try lock failed. And so this debug message is just for now. I wouldn't actually print this in the patch, but it's sit there stuck. But I can always control C out of it now because the ioctl returns and we sleep for a little bit and try again. And then if I just use my little hack to release the lock, suddenly the command completes successfully. So now all the commands you would do are actually killable, at least, instead of being stuck forever, giving the user a chance to get control of their terminal back in those situations. When the server's half jammed up and a bunch of commands are going to freeze all the time, sometimes you just really appreciate being able to cancel something. Although doing this and other testing, I thought it'd be really handy maybe to have a secret module parameter that you set it to 0 and it would drop the SPA namespace lock. I think it's a really bad idea, but it's happened enough where it's like, if it's this or reboot, maybe I'm okay with that. Or maybe you have to say, I promise this is not for evil or something, but whatever, it might be useful. But anyway, I only got zpool clear working. It turns out I had to already do 3 different ioctls to make that work because it tries to get stats about all the pools and then it tries to open the pool and then it runs the clear ioctl. And so zpool list is almost working, but I think there's 1 or 2 more ioctls I have to fix still and teach to do this. But if more things can do this and when you teach user space to do the retry, I think that's interesting just to be able to have stuff fail. Originally what we looked at was instead of doing mutex try enter in all these places, if we had a version that would like just time out after 10 seconds so that you had a bit more of a chance to wait, because on a very busy system, it feels like going back all the way out to user space for each retry might be a bit of a pessimism, but there isn't like mutexes don't have that option right now. So I think this is good enough. Any questions? No? Okay, thank you.
Cool.
Does people from the FSX team want to talk about the metastat stuff we did as well?
And since I was absent for most part of the people who worked on it.
Yeah, I could talk. You want to show what you have?
Yeah, I could talk a little bit
about that.
Yeah. Do you have something to show?
Yeah.
Oh, awesome. Because my version's like only got open.
And
There's the other one here.
used to see.
Use that.
Yeah. Awesome. Yeah, so I was just pulling this up to give Seraphim some credit there. He previously introduced a patch for k-stats per data set for reads and writes. And that was something that we mentioned, or Sitapti mentioned yesterday in her presentation, that we were interested in getting something similar, but for the different metadata operations. And so it ended up being pretty straightforward, thanks to Alan, Tony, and Seraphim for helping out with this. But they helped to get the groundwork running there, but I've just got a super simple Z-pool set up here. And this is some of the existing case stats. You can see we've got these like reads and writes that were already existing. And then at the bottom, we've got some additional metadata accounts that we have added today. And so I just imported the Z-pool, so it's mostly empty right now. But if you go ahead and make a new directory, refresh that, you can see we've incremented that.
Yes.
Likewise there. And then just interesting going forward, having I added the create and the open operations. So right now, I already have this existing file F1, so I'll go ahead and just create a new one. New file F2. And then when we print that out, for now we made the decision to add a create counter as well as the open counter. And when you open a new file with ocreate, we go ahead and we bump both of those counters there. So that added for twice. But then if you did anything to overwrite that, then we're just gonna bump the open. So I'm sure that there will be similar scenarios that we run through as we add all of the other metadata operations. But yeah, that's what we've got for now.
See?
How do you spell your name for the spreadsheet?
Patrick?
I don't have anything to show, not that I produced much, just a few unrelated lines. But my idea for today was to investigate a couple of optimizations. As I've told, it's critical to have prefetch in many cases, and many people ask such configuration as speculative prefetch for uncacheable data, when you set primary cache to metadata, but still want to get data prefetch. I investigated whether it's possible, because I have feelings many years ago, it was me who partially disabled that. Maybe it was broken, I don't remember where it all started, but the fact that we are not prefetching data if we set not to cache them. And it seems like it should be possible, but there's one edge case. If data are not claimed, not read, they will not be expunged from Arc. They will stay there. The problem is that all that handling for primary cache is done on DMU layer. Arc doesn't know anything about it. So we need some other eviction methods to handle it. So I'll continue thinking about it, just haven't succeeded yet. Just mostly looked how it works. My second, even more crazy idea was to avoid one memory copy during read process for uncacheable data. Because if we are reading data which are uncacheable, they're probably not going to stay in cache. And if they are uncompressed, that it makes no sense to make them ABD. If we read them into linear buffers, then we may share them with the DMU buffer. And instead of 2 reads or 2 memory copies, get only 1. Problem again in details. First, something else may try to read data in parallel and from different clone. And again, they will stay in Arc, but in this case, they will be linear buffer. We may get out of KVA. That's not good. And another question, like when to evict and how, there are still some details, but I'm still not dropping the ideas. I will continue investigating.
Are you using HDMI?
Yeah, I'm
You have to
trying.
switch the input on the TV then.
Okay.
I think the other cable might work better. It's a little longer.
Where's the other
This
one?
one.
Oh, this is just USB-C.
Yeah. Should be the right one. There you go.
All right. So after working on the Cherry stuff and talking about the envy list, coding, all that stuff, I decided I wanted to do some actual hacking and write some code. So I went to the spreadsheet and found a sample project, which was ZStream recompress. So we have the ZStream utility that lets us do various manipulations on ZFS send streams. And you can use it to analyze send streams. You can use it to modify them in certain ways. And one thing that could be useful is the ability to rewrite an existing compression algorithm to a new compression algorithm. If you wanted to take your send stream and make it smaller using some hot new compression algorithm. So for a test, I set up a small file system with some compressible data. I wrote the stream, I created a send stream that was compressed. And then I run this command, which is cat stream into ZStream recompress. And there's a lot of debugging output because it mostly doesn't work. But in this very specific test case, so the original stream is on the right. And you can look here and see we've got a write record for object 2. Compression type is 16, which is Z standard. And you can see here that there's a 128 kilobyte logical size and a 50 kilobyte physical size. And the corresponding record on the other side has compression type 0, which means uncompressed, a logical size of 128 kilobytes, and a compressed size of 0, which indicates that it is not compressed and is stored raw. And the checksums validate, and the whole thing looks good. I've never tried receiving the stream, so it probably explodes horribly. But at least for the case of going from one compression type to uncompressed, it works well. If you try to compress instead, it breaks because you need to actually initialize the compression algorithms, and I didn't do that step yet. But the core loop of the code does seem to work correctly. So this is a good jumping off point for the rest of the patch.
Do you need to do the recompression there? Because if you make it uncompressed and then pipe it into ZFS receive and you set the property, it can compress it then.
Yeah, you certainly could. This would be for if you wanted to continue storing it as a stream for some reason, as a backup file or something.
Was this
like
based
that.
on the existing pull request for ZStream decompress?
This is ZStream decompress is in the repo, and so I ended up copying that code and using the loop part of it, and then re-implementing the actual core logic.
Would it be possible in theory to add encryption on the flight? To receive that encrypted stream?
Possibly. It seems like it should be possible to add or strip encryption through something like this. You would need to add the separate processing steps for that and do the key management and stuff like that. But there's no reason that I can think of why it shouldn't work.
Yeah, I remember Pablo and I talking about that at the 2018 hackathon, I think it was.
Yep. Okay, thanks.
Thanks. I don't want to interrupt, but my wife is downstairs to pick up. It was so great, guys, to see you all in person. So I have to go. Thank you very much.
Nice to see you.
Seraphin, you? And Linda, if you want to present, add your name to the list after that. You're the last one signed up.
All right, so we should be fairly quick. Oh,
Everyone can read that, right?
that is interesting. Let me try the other one. Okay. I'm very sorry for this. I'll try.
It's just really small.
Yeah,
You might just be able to do like Command plus to increase the font size.
yeah, but I think that's not gonna increase the window, right? Well, anyway, can try.
I don't know why it's only half of it, but at least
Yeah,
you.
I also had some plain graphs too, so
Oh.
I'm not sure how to.
Oh, there you go.
Okay, I'm working. All right. Yeah. So, after talking more with the FSX folks, I was reminded of a problem of the shrinking zap. Specifically, if you have a directory in the dataset and you just, create like 1,000,000 files, and then you delete, almost all of them, there's still like zap entries in the directory. So like for every new file, there's a new zap entry. And even though we remove those, the zap doesn't actually shrink. After talking with Matt and looking around on the web, I managed to reproduce the issue and also revive some old pull requests from Illumos, where we are basically slowly shrinking the zap when zap entries are removed. So over here, I have a directory testdir where I basically created 500,000 files and then removed them. And just taking the real wall clock time, we can see that on the system we spent around 0.2 seconds, while on the clean directory with like 2 files, we basically spent almost no time. So after applying the patch and removing a couple of files and basically trying to reproduce the issue, we can see that the system time is being reduced by a lot, but still there's some work to be done. After applying this patch and reproducing the issue, I tried to casually look at like how the zap works and what the PR is doing, and I think there's certain things that we can do slightly different or completely change the way that we go about this. But I just wanted to showcase kind of like the problem here with flame graphs. So that's the ls command that I did on the issue on the machine that I reproduced the issue, and as we can see, we spend like the majority of the time in the zap cursor retrieve code where we go through the zap, and this is how things. And by the way, this is like almost like 24 million samples with perf. And on a clean system, you can see here it's around 1 million samples, and the zap stuff don't even exist. Probably because it's still a microzap. So, but here is the same system with the patch where we still have a fat zap, and we see there's like 4 million entries. So there's definitely like a big speed up just with this patch. So what I ended up doing is I have my ported code up on the branch, and I'll probably create like a draft PR. For this, the code is really not that much, but I'm not sure if that's exactly what we want to do. But I think it would be a good starting point to just start to talk about this issue again. Thank you.
All right, who else has something to present? All right, Paul. I worked on showing the RAID-Z expansion code to some folks, so hopefully we can move that year by year, a little closer to being done. So we're almost done with the day. Let me send out a link with a survey so you can vote on your favorite hack for today. And we do have prizes that are not here right now, but we'll get them shipped to you. So for the 3 favorite ones, do you have a question?
So I actually forgot to mention one thing that I was hoping to add as an addendum. So with CodeQL, it's actually possible for us to write our own static analyzer checks. So we can actually, if we notice a certain pattern or bug, we can actually write a check for that and add that to the repository so that we can try to catch other instances like future recurrences or other existing instances. I think NASA did that with some of their code, but anyway, it's just another possibility this opens up. And it occurred to me I probably should mention that. But yeah, that's my addendum.
I'm gonna post the link just a sec. All right, I posted the link. Okay, great. Somebody voted on these. Please vote for one. We'll give like a couple minutes. Let me see if it works on my phone. Right. While people are voting, I'll tell a story that may or may not influence your voting. So I joined Delphix like almost 12 years ago, and one of our colleagues set up a home directory server that was based on actually I think the Sun FishWorks appliance that uses ZFS inside of it. And it's all administered by IT, and like we don't have any access to it or anything. I just have my home directory. And then like maybe 3 or 4 years into it, I was writing some tests. And the test was to test like how ZFS performed with large directories. And so I was creating lots of files and to see how fast could you create like 10 million files what if I use lots of threads? And I thought I was running this on like a test system. I was running on a test system, but I thought I was running it in a test pool, but actually I was running it in my home directory. So then I got to test how long does it take to remove 10 million files over NFS. The answer is a long time, but which is fine. But for the past like 8 years, every time I go into my home directory and try to tab complete something or ls, it takes like 60 seconds. And it's not because I have a lot. I mean, I have like 1,000 things in my home directory, but it's not that many. The problem is like the NFS server is running ZFS, and it has this fat zap that has tons and tons and tons of leafs, and it's like iterating over all of it because at one point I had 10 million entries in there. So that's why I voted for Seraphim. Looks like anybody still working on voting? Okay. Okay, maybe I'll use this. Just trying to see like how many laptops can I use at once. Right. So the results. In first place, Alan Jude unsticking the spot namespace lock. Congratulations. Oh, in second place, maybe I did sway the vote. In second place, Seraphim with Zap Shrinking. Congratulations. And in third place, Patrick and collaborators, the metadata case stats. Nice job. So I will contact you all to get your shipping addresses. We do have multiple prizes, so everybody that worked together with you, let me know. We should have enough for everyone who worked on those 3 projects. All right. I think that might be everything. Where's down here? I think that we should probably try to put the tables back the way that we started. I don't think there's any particular time we have to be out of here, but probably like the next 15 to 30 minutes. Any other questions? It was really great to see you all in person. I know it's been a long time, so it was nice to see everyone. Hopefully we can do this again next year. We did a decade. This is the 10th annual. So was anybody, who else was at the first one? I know a couple people. Yeah.
Maybe, I don't remember.
Yeah. So if only maybe 5 of us. So yeah, it's been a great 10 years, and hopefully we'll have 10 more years of great OpenZFS development. Thanks.
I can take a picture of the booth setup.